Yeah, you guys can be hearing. Sorry. Don't if you are don't be calling my line. Tell your friends to stop calling my line too, because as you are calling this line, you are breaking my connection. I'm not using a MiFi here. You get? I'm using my phone as my hotspot. So if you keep calling, you keep disconnecting. At this point, I'm so sure you can hear me. If you are, don't be calling my line. Tell your friends to stop calling my line. You're breaking my connection. I'm not using a MiFi here. Send it to me now.
Okay, you want to.
My hotspot. So if you keep calling,
Click on the go subscribe the one watch. Let's go to this lounge. Subscribe there and get the video.
Oh yeah, oh yeah, oh yeah.
What you can hear me?
They can actually.
Okay, Lord.
They are supposed to subscribe now.
Please subscribe.
Person
I don't know.
this thing again, you're going to eat me raw. God's sake.
Send it again. They are the ones causing it. Please, if you are joining the class, don't be cutting the connection. If you are keep calling.
Why did you tell me that one? That's what I'll be in. It's just that it was yeah.
Yeah, you can very much.
Yes, you can sing if you have issues.
Really Christian song.
What? What? Are you sure? What happened?
Not only that, actually this class is going on. Oh, wait a minute. Good. That's our business. And I'm like, please, oh, no. What made the TikTok this in fact, right? Like, is what's happening? Is this just me or is this
Okay,
just
please
one question and
do
like
not
I can't even hear the teaching.
do not do not call me directly. And this the more you are calling me, the more it's breaking the connection. Okay, thank you.
Oh, this is nice. So supposed to be reading. The person is reading TikTok.
You children, you are supposed to be. Why are you talking about people like that? Oh God. Sorry, the class is about to start for some of you. I'm just setting up so that everybody gets the link and then gets to join the class. Hey, I'm saying stop calling me and somebody is calling me. Hello. Auntie. The class I'm just trying to set up, send the link to every other person so that they can get. Use this and make sure you don't call my line.
Is it that you freezer? Is that what I have? No.
Okay, the class will start soon. Use this.
What's your problem? Right. Cannot say it here.
Okay, if you are live and you can hear me, just indicate. Okay. Sorry, make I just.
Use that character safe for me. It's Tuesday. We don't do water.
Yeah, I take water. This one is
No, I don't like
cool. I like
water
water.
where them don't pour
No,
inside can.
no, the not for this brand new
Someone has
aquafina.
already drank it.
No, it's cold. Don't want cold water.
No. This one is not mortuary standard.
No, I'm not understand.
Very cool.
Why negative connected?
Okay. I'm just trying to. I'm trying to get everybody to get the link. So please do not. Do not. We are about to start the
Wait,
class.
do you know
We're about to start the class. Let's just get the link across to other groups so that we'll start immediately.
Wow.
MDA.
What's that?
Okay. Remember not to call my line, please. Don't call me directly. We're about to start. Great. Thank you.
Never call my name.
Sit down.
Quincy.
You are sister.
Concentrate. You know, I don't like it. Because the bones of the man.
DPS you're making or
Sorry,
DPS
Quincy.
6 7 days man. I want to forever.
Mature noise.
Yeah.
You like it. You like a lot. You know what I'm like.
But I'm on down.
Me is that question.
Okay, I think we can now start the class.
Hallelujah.
If can I have somebody's phone? Just
Are
to
you piano?
yes. Can I have someone's phone? Thank you. We should be able to start the class now. Okay. Please, if you can hear me, just if you can hear me, just indicate.
It's not good. You have a name. Could you put this get? Could you put the gift? Are you done?
No.
Yeah, iPhone.
I'm usually writing exams for me.
Okay. Yes. So let's start. So what we're going to be doing in today's class is, please, we don't start class. Those here. Let's sit down if you want to join this class. You are not sitting down. Okay. So for those of you that are already online, let's just get into it. What we're going to be doing throughout in this class is solving as many questions as possible. We would start with, okay, I already have some questions on the screen, so we're going to start with those ones and then move ahead. Now, what's going to be happening is, if we take the question, we explain things around it, and then move on to other concepts. Okay, so starting the class. The first question we can see on the screen is, if 300 cm cube of oxygen diffuses through a porous plug in 7 seconds, how long will it take 60 cm cube of chlorine to diffuse through the same porous plug? Okay, so those of you online, you can send your answers. You don't need to see me. You don't need to see me, but you can see the board clearly. That's the most important thing.
Okay.
Okay, so you have 30 seconds for each of these questions to attempt. If I have an answer, once I see an answer online, I would solve the question. Okay, is there any answer? Any answer here? Mm-hmm. You can see the question. What do we have as our answer? Okay, 30 seconds don't pass. Oh yeah, I'm going to solve this question. Now, why I'm working with 30 seconds is practically you have about 40 seconds to solve each question. If you check it, you have 80 questions to solve in 120 minutes, which averages each question to 40 seconds. So you guys are going to be solving with 40 seconds. What I'm going to do now is to solve this since nobody has gotten it. Now listen, whenever you see a question and you notice that in that question you are asked to find rate of diffusion, or you are asked to find time, or you see the term how long or how fast. When you see how long, it means time. When you see how fast, it means rate. What do you simply apply? Graham's law. Now, Graham's law is quite simple and it's easy to express. Mathematically, it is given as rho. Sorry. So it is like an inverse. What did you guys do to my screen? All over square root of RMM1. Have that in mind. So, with this said, I would also like to mention that rate is equals volume over time. So, which means that if you have a question where you are not relating rate and relative molecular mass, but you're expected to find time, how do you do it? After you are done solving for the rate, you use this particular relation to find the time. What is it going to be? T is equals V over R. So have this in mind. So as much as possible, let's put these formulas down. Rate 1 over rate 2 is equal to square root of RMM2 all over square root of RMM1. This is what we refer to as Graham's law. Okay, put this down so we'll now consider the question. Put this down so we'll consider the question. Okay, so I think at this point you must have written these things. Now, to solve this question is quite simple. Let's look at our parameters. That's what I do first. The question says, if 30 cm cube of oxygen, so the first volume there is the volume of oxygen. Volume of oxygen is 30 cm cube. Then we have diffuses through a porous plug in 7 seconds, which means that the time of diffusion of oxygen is 7 seconds. How long will it take 60 cm cube? Which means we are looking for the time it will take 60 cm cube. We are looking for time. But then the volume we are dealing with of chlorine is 60 cm cube. How long will it take 60 cm cube of chlorine to diffuse through the porous plug? So you have that in this question, we don't necessarily have a direct relationship between time and between time and volume necessarily. But then to solve this is going to be quite simple. What's the first thing we know? We know that rate of oxygen all over rate of Cl it equals square root of, if you remember I said the RMM of this one will now be up, so RMM of Cl. Do we understand? Do you understand what I'm doing? All over the square root of the RMM of oxygen. Now, if you have this arrangement, the first question you are going to be asking yourself is, do you have the rate of oxygen? No. But can you find the rate of oxygen? Yes. How do you find the rate? R is equals V over T. Do you all remember? Okay, so with that said, let's find the rate of oxygen here. What's the rate of oxygen going to be? It's going to be 30 all over 7. Why is it 30 over 7? The volume of oxygen is 30. The time for oxygen is 7. So if you do that, what do we have? 4.29 cm cube per second or whatever per second. So this is the rate for oxygen. Now, we don't have the rate for Cl, and that is what we are going to find first using this particular formula. Now, mind you, RMM of chlorine is 71. If you do not know this thing, how did I get it? Chlorine's atomic mass is 35.5. But inside every chlorine gas, there are 2 atoms. So 35.5 times 2 will give you 71. Then the relative molecular mass of oxygen, oxygen is O2, so 16 times 2 is 32. Oh, no, sorry, 32. With that said, let's put this together. Now, what is the rate for oxygen? The rate for oxygen as we got is 4.29 divided by the rate for chlorine is going to be equals square root of 71 all over square root of 32. With this said, can we resolve this? I would have to take this out of the screen. I'm taking everything out of the screen, so I presume we understood this. So if we are doing this, what we have is 4.29 divided by R of Cl equals square root of 71 divided by square root of 32. What did we get as the square root of 71? Those of you that have calculators are here. You are my calculator buddies. What do we have? 8.43. The square root of 32 is what? 5. What? 66, right? Good. So when we cross multiply, the rate of Cl is going to be equals what? 4.29 times 5.66 all divided by 8.43. What is it going to give us? Yes. What do we have?
2.88.
As the final answer, right? 2.88 whatever per second. That's cm cube per second. Now, the question did not say find the rate of Cl. It says how long, which means you're looking for time, right? Now, remember, if you have rate and you are asked to find time, it's very simple. Rate is equals volume over time, which means time is equals volume over rate. Time is equals volume over rate. In the question, let me bring back the question so we'll see it. The question, yes, where is the question? So if you look at the question, we were given 30 cm cube of oxygen and we are asked to find how long it will take chlorine. The time for chlorine is going to be the volume of chlorine. According to the question, what is the volume for chlorine? 60 cm cube divided by the rate. We found the rate. And what is the rate? 2.88. So when we do that, we are going to now have, okay, sorry, I meant to left the screen. We're going to now have, the volume is 60. What is the rate we got? 2.88. When you divide that, the time is going to be equals what? What do we have? 20 point something seconds, right? 20.8, which is approximately 21 seconds. And our answer for this question is C. So you have that. The most important thing you need to take note of to solve this question, number one, is that rate is inversely proportional, which means when you have a rate of an element on top, you will have that the relative molecular mass for that particular element on the other side will be down. If R2 is down, RMM2 will be up, basically. So when you have these questions and you notice that the volume is not the same thing, find the rate first. And then when you find the rate, use the rate to find the time. Now, there is another version of this question. And then that version of this question is when you have the same volume. If you're looking at this, oh wow, my screen is, I forgot to take this out. Forgot to take this out. Let me do that quickly. Sorry, guys. Okay, so I guess you can now see the formula I was talking about. Sorry. Okay, so the other version of this particular formula is this. There are conditions or situations where you see a question. Once you look at a question and that question is dealing with rate, but they say same volume. Once you hear the term same volume, you use a different formula to find time. And that formula is quite simple. T1 all over T2 is equal to square root of RMM1 all over square root of RMM2. In this case, you notice 1 on top, 1 on top, 2 down, 2 down. But here, rate 1 up, the RMM will be down. Meaning that in this case, there's an inverse proportionality. But here now, there's a direct proportionality. Please, this formula is only used to solve for Graham's law if volume is constant. If volume is constant. What do I mean by if volume is constant? If they tell you that the volume is the same, that is the only time you use this particular formula to solve this question. So I take it again. If you ask find time normally, time means how long. We would have used this find rate first, and after finding rate, that is with this formula. After finding rate, we will now get. After finding rate, we'll now use the rate to find time. How? Because we know that time is equals volume over rate. This is what we're supposed to use. But this one is used when they did not say that volume is constant. But once you look at the question and you notice that volume is constant, how will you know? They will tell you maybe 30 cm cube of this gas and 30 cm cube of another gas. You notice that 30 cm cube, 30 cm cube implies that the volume is the same. Or maybe you see statements like given that the volume is the same or given that the volume is constant. So once you have all those statements, just know that you don't need to bother yourself. Once volume is constant, you use this one. T1 over T2 is equal to root RMM1 all over root RMM2. Okay, now let's try this. Let's try this other one. Let's try this other one quickly. We'll try this question. Based on what I just said, you all try this question. Okay, I presume you can see it, so try it. Everybody try that question. You have 30 seconds. So it's more like the first one, but there's a twist to it. Give me answer already. 40 seconds. Okay, what do we have? Those online, we are still waiting for you people to be fast. Give us an answer. I know it's lagging like somehow, but you know. And those of you that are online, you can increase the quality of your video to at least 360 if you want it to be clear. Increase the quality of the video to at least 360 if you want it to be clear. You get, because some of you that are complaining that you can't see it is as a result of your video quality is bad. Okay, someone said C, which is 40 seconds, and that is Neji Kingsley. Okay, Neji Kingsley, I think you are correct, but you know, we can't say until we solve. Now, let's get to work. Let's read the question first. Please, now, this thing is entering here. You are making noise and it's getting into my sound. Okay, so let's get to solve. Now, if you look at the question says a given volume of methane. So the first gas we have there is methane. I presume that everybody that is preparing for JAMB should know that methane is CH4. If you don't know that methane is CH4, go and start praying to your father because you are likely not going to pass. But let's continue. Now, a given volume of gas of methane diffuses in 20 seconds. So which means the time for methane is equals 20 seconds. Okay, now they now said how long will it take the same volume? Now I would like you to take note of the fact that we just said same volume, and once you hear same volume, I told you to find time when you have same volume is that second formula I gave you. So because they said same volume, we are going to be using T1 over T2 equals root RMM1 all over root RMM2. Why are we using this particular formula? Because in the question they said same volume. Once you hear same volume, it implies that you are supposed to use this particular formula to find the time. Anyways, let's continue with our question. So we said the time for methane is 20 seconds, and they said how long will it take an equal volume of sulfur 4 oxide, which is SO2, we don't know the time, to diffuse. Now, for us to solve this question, we said we are going to be using T of CH4 all over T of SO2 equals root RMM of CH4 all over root RMM2. of SO2. Why? This is a direct proportionality. And why are we using this? Because they mentioned the same volume. Now, to be able to solve this now, what do? We need the relative molecular masses, and that's quite simple to solve. Relative molecular mass of any substance simply means that you need to add the atomic masses. If you look at the question, they said C is 12, right? So let's find the relative molecular mass of CH4. C is 12 plus hydrogen is 1. Then that 1 is into 4 places, so 1 times 4, which means the relative molecular mass of CH4 is going to be 12 plus 4, which is how many? 16. I presume this is understood. Then the relative molecular mass of SO2 is going to be S is 32 plus oxygen, which is 16 times 2 is also 32. And what do we have as our answer? 64. Now, let me just remove the question so that we can be able to see the other side of the board. Yes, where am I? Okay. Okay, so I presume we can see it now. Now, so having said this, you will find out that if we are to solve or apply this thing now, we are going to have that the time for CH4 is 20 all over. Remember, CH4 is 20 all over. What is the time for SO2? Do we have it? No. It's going to be equals the square root of CH4. Square root. The relative molecular mass of CH4 is 16 divided by the square root of the relative molecular mass of SO2, that is 64. And if you do this, everybody in the whole wide world should know that the square root of 16 is 4 and the square root of 64 is 8. So when you cross multiply, what you're going to have is TSO2 is equals 20 times 8 over 4. Cancelling out, you have 8 over 4 is 2, right? 2 times 20 and you have 40 seconds. I hope this is understood. So those online, hope you are following. Yes, C is the answer and that is correct. Okay, we'll have to go to the next question. Remember, we said all we're doing now is just solving questions. Now, if you have questions with respect to what I have just solved, send in your questions. I'm actually reviewing the live chat right now. Anyway, the question never entered, so we'll just continue with the next one. Now, the next question we are going to touch is one question that always seems to confuse most students, but it's actually very simple to understand. Now, let's look at this question. Anytime you see a question like this in which the options are constant composition, conservation of matter, multiple proportion, definite proportion, just note that your answer is either constant composition or multiple proportion. Okay, there's a scenario where it can be conservation of matter, but then I'll talk about that. But most times when you see this kind of question where the options are these four things, your answer is either going to be the constant composition or multiple proportion. So just have that in mind. Now, there's a little problem with these options. Constant composition and definite proportions are practically the same thing. You get? I think I should have this. I didn't put the options correctly in the right order. So constant composition and definite proportion are supposed to be the same thing. What should be on this? Something like reciprocal proportion. But as I said, once you see a question like this, your mind should go to two things: constant composition or multiple proportion. Now, let's show you how to solve it. How would you now know which of them is the answer? Let me try to reduce the size of this thing so that I'll have space for solving. Okay. Okay, you can still see it, right? You can still see the question, Abi. You sure you can see the question?
Yes.
No, this is no get slim down. Like you know get the side. OBS is just work. Okay. Sorry. Did I just diss OBS on live TV? Okay, let's continue. Now, having said that, let's get to solve this question. Now, how do you solve it? Very simple thing to do. I presume everybody here knows what mass composition or mass proportion is. What do I mean by that? First of all is this. You look at the question and write out what you have. They said 2.25 grams of a sample of an oxide of copper. So which means this 2.25 is not for copper. It is for the oxide of copper. So we don't know what oxide. So we just write CuXOY. And under it, what is our mass going to be? 2.25. They said this 2.25 gram of a sample of an oxide of copper on reduction gave 2 grams of copper. So which means the copper in this particular sample is how many? Is 2 grams. Okay, we keep solving. They now said these results are in accordance with what law? Okay, sorry, I think I missed something. Yes, sorry, let's take the question again. It says 2.25 grams of a sample of an oxide of copper on reduction give 2 grams of copper. So 2.25 give 2 of copper. Then they now said 2.5 gram of another oxide. Okay, so we have another oxide. This is sample A and this is sample B. That other oxide of copper is 2.5 and they said that 2.5 gave 2 grams of copper. Now the question here is this: with these results for these two samples, what is or what law is applied here? The very simple thing to do to get your answer is this: if you do a division of one of the elements, we can find oxygen. Can you give me the mass of oxygen here? What will be the mass of oxygen? The mass of oxygen here will be 0.25, right? Do we understand?
Yeah.
It's 0.25, right? And that of oxygen in the second one will be 0.5, right? Good. Now, to know if it is definite proportion, what you simply need to do is take one of these elements, any of them, and use the product. Sorry, I meant to say the compound. Divide it. What do I mean? You find the proportion of this element in this compound. So for element A, we are going to do 2 gram divided by the compound. What is the compound? 2.25. Check. Then for element B, we do the same thing. Whatever mass we have here, 2 divided by 2.5. What do we have? If you divide this, what do we have as our answer? What do we have as our answer?
0.8.
0.8. What do we have in this case?
0.8.
0. Are you guys?
First one should be 0.9.
Yes. Whenever you are solving a chemistry question, it's important to note that you should at least solve to at least 3 decimal places. You get what I'm saying? So please, 3 decimal places, 8, 8, 9. Okay, good. Then here is what? 0.8. Now, once you have this kind of scenario, if the proportion is not equal, the answer is multiple proportion. Just have that in mind. You can put that down. That once you check the proportion of elements in both samples and they are not the same thing, the answer to this question is what? Multiple proportion. So the answer to this one is C. Now, if, for instance, you perform this experiment and you notice that their proportions are the same thing, that is when you now say constant composition. Once you solve this thing, any of the elements, you can pick this one, you can pick this one. Okay, let's even try it with oxygen. Let's try with the mass of oxygen and see. So trying it with the mass of oxygen, what we are going to have instead is 0.25 out of the total 2.25. What do we have? And then B would be 0.5 out of 2.5. So what do we have here? 0.111. Okay, then here, what do we have? 0.2, just 0.2. Okay, very good. So you notice that whichever one you use, provided it is not going to give you equal answers, automatically what you have as your answer is multiple proportion. But once this thing is equal to this thing, it is definite proportion. Okay, let's try a question to see if we grabbed what I just said. Those online, are you following? Okay, Aniagume Soma, probably you joined the class late, so you would have to wait for the question to start afresh so that I will explain properly. Okay, I'm going to put out a new question. So, but for this one, what did we say is the answer? The answer to this one is what? Multiple proportion, which is C. Okay, let's try this one. Let's try this one. Let's try this one. Let's try, attempt. Everybody attempt this question and see what you think. Is it going to be definite proportion? I told you, if it is definite proportion, when you do those proportion of the elements in the compound, you are going to get equal values for the two samples. But once you have different values for the two samples, it's multiple proportion. It's just one trick you can use to just easily know it. If you have the same values, so those online, please solve. Mesoma Joy, you are confused. I'm going to solve a different question, and when I solve it, yes, Chisom Favor. constant composition and definite proportions are the same. I mentioned that earlier. It's like a little bit of a mistake or error in the options you get. Constant composition and definite proportions are the same. How did we get the mass of oxygen? I think I'm going to solve. You will understand this thing when we solve the next question. So please, chill. That's Flora and Nena. When we solve the next question, you understand. Okay, so what do we have? Multiple proportion. Okay, so I'm going to solve it again and re-explain. Now, the question on the screen says that let me get my 2.85 gram of an oxide of copper. Okay, so oxide of copper, which means CuXOY is an oxide of copper. We don't know what oxide of copper is. They said it is 2.85 gram. And they said it gave 2.52 gram of copper. So 2.52 gram of copper. Okay, let me try to shift let me shift it a little bit so that it can accommodate more. Okay, so I take it again. 2.85 gram of an oxide of copper. So which means CuXOY is 2.85 gram. You're distracting my class. 2.85 gram. And they said it gave 2.52 gram of copper. Now, the second part of the question now says, and 1.9 gram of another oxide of copper. So, which means a different oxide. This is A, this is B. In B, we have 1.9 gram, and they said the copper is gave is 1.52 gram. Now, with this now, somebody is asking, how did we get oxygen? It's quite simple to understand anyway. How did we get oxygen? I just want to How did we get oxygen? Sorry, let me write this thing so that it would fit in properly. So CuXOY, you have 2.85, and copper here is 2.52. Here you have 1.52. No, sorry, 1.9, 1.9, and here you have 1.52. Now, to find the oxygen, someone asked a question initially, how did we get oxygen? It's very simple. Copper and oxygen together is 2.85. So how do you get oxygen? It's very simple. Now, you have that 2.85 is equals copper. Copper is 2.52 plus oxygen, O. So how do we get oxygen? Oxygen will now be equals 2.85 minus 2.52. So in this case now, oxygen here is how many? What do we have?
0.
So here is 0.33, right? Good. Then oxygen here, how do we find the oxygen for this? This is sample A and this is sample B. Keep that in mind. So in sample A, the mixture of Cu and O is 2.85. Cu alone is 2.52. So oxygen is this minus this. Do the same thing here. What do we have? 0.38. Good. So we've gotten the various masses of oxygen. Now I'm going to take away this question from the screen so that we would use the other side of the board. Okay, so that done. Now listen, what this simply means now is that we need to find the proportion. How do you find proportion? Proportion is quite simple. Is the element all over the total you get. So let's use copper to do it. If we do 2.52 of copper in A, this is for A, this is for A, this is for A. If you do 2.52 out of the total, which is 2.85, what we are going to get is what? What do we have? 0.884. Very good. Then for B, the second guy, the copper in the second guy is 1.52 divided by 1.9. What do we have? 0. What? 8. So if you notice now, the difference is clear because if you approximate this is 0.9. And because they are different, what are we dealing with in this case? The law of multiple proportion. Am I communicating with you? Good. I would look out for a question that has to do with definite proportion and put that out later. Okay, so I presume you understood this. For those of you that are still with us online, let's go to the next question. Remember, all we are doing is pick out the question, explain the concept around it, and then move on. Okay. Now, the next question we are going to get into. Okay. Okay, it's an organic question. Very good. Let's look at the board. In the screen, the question says, the IUPAC name of this compound is dash. Those online, please give us your answers. Those here, please give us your answers. What is the IUPAC name? Write it down. Put it out. Write out. Huh? We think it's D, right? Okay, so I will just briefly go through the principles of naming. It's quite simple. Once you have a chain, I like drawing out my own chain personally. C, CH, double bond, CH2. And then I have that the methyl is here, CH3 and H. I have discussed this before, but I think I need to mention this again. There's something referred to as the order of priority. In the order of priority, you have that the highest order or the highest functional group is the alkanoic group, which means let me see if I can just put it out. Just give you a list of those things quickly. Let me take this. Where is my mouse? Okay, sorry, don't mind me. So let me just remove this and okay. So write out the order of priority quickly. Now, the order of priority, you have that the highest order is alkanoic acid. After the alkanoic acid, you have your esters. After your esters, you have amide, you have nitrile, you have aldehyde, you have alkanone. Now, please mind you, aldehyde is the same thing as alka. Now, when you hear the term aldehyde, it is exactly the same thing as alkanal. Alkanone is the same thing as ketone. So after that, you get to your you get to alcohol. Then you talk about your amines before you talk about uh that's alkynes, alkenes, what else? Haloalkanes, the halo, and then the alkanes. Now, why did I put all these things down? This order now means that if you see a structure like this structure, the first person that will take the highest priority is alkanoic acid. If you are giving numbers, you're going to start numbering from the one that has alkanoic acid. But if you look at this our structure, we are not seeing alkanoic acid. What are we seeing? Alkene. Why are we seeing alkene? Double bond is alkene, which means that since there is no other one to consider amongst these ones, we are going to consider alkene first. What that consideration implies is when you are given the number, you are going to start from the side that has the double bond. That's all. So in allocating your locants, you start from the side that has the double bond. If there was a triple bond here, alkyne is above alkene. So we are going to consider alkyne before alkene. Well, let's name this one first. Then I'll give you another one to name. Now look up. What is this going to be? I have CH3 C, CH3H. I have CH double bond CH2. Okay, so remember we are starting from this side because that's double bond and that's the highest priority for now. 1, 2, 3, 4. The infix for 4 carbon atoms, I like circling my own parent chain. Oh, sorry. So my own parent chain, that's my parent chain. Okay, good. So the infix for 4 is but. However, we have an alkene, and that alkene is located between number 1 and number 2. So this is but. Whenever you have a double bond between two numbers, you choose the lower number. If you have a triple bond between two numbers, you choose the lower number. So this is going to be but 1 in. And that's that basically. Now, but we forgot that we have a substituent here. This substituent is methyl. Where is he located on? Number 3. So this is going to be 3. Oh my god, no. There should be a hyphen between every number and a letter. So 3-methyl but 2 in. And invariable puts 1 in. I'm sorry about that. 3-methyl but 1 in. And that is our option number what? What did we say it was? That should have been option D. Okay. So with that said, you guys should try this question. Try this structure. What is the name of this compound now? let's say we have this. Let's say we have this, and then I have CH3 here, and then I have CH3 here, and then I have H3. Okay, so let's try those online. Yeah, 2, 3. It should be dimethyl. Okay, so those on. And what's his name? Pushi Autumn is not butane now. It's butene because of double bond. Pushi, I mean Pioche. Okay, yeah, Pioche. I think you're correct. You said it's 1, 3. No, it's not 1, 3 now. It's 2, 3. Pioche, what are you doing? I mean Autumn. Let me call you Autumn. Yes, is there any other? Okay, those here said is this. Okay, let's name this. Now, if we are going to be allocating locants, are we going to start from this side or from that side? Are we going to start from the left or from the right? From the left. Why? Because the left side is closer to the double bond. So you start counting 1, 2, 3, 4, 5. Now 5 is pent. You say pent. When you say pent what in is between 2 and 3. I say take the lower number. So pent 3. Did I just say 3? No, no, no. Pent 2 E. Now, as I said, I like circling out my parent chain. And when I circle it out, I'll notice that I have 2 substituents and they are both methyls. Where are they located? 2 and 3. This is going to be 2, 3. How many methyl? Dimethyl pent 2E. I presume this is fully understood. Now, let's continue. Now, having said that, we go to the next question. Next question. If you did not understand, you can indicate and possibly we may come back to that. Now, the next question. Okay. Okay. So, the next question, I think it has to do with electrolysis, as you can see. Okay, so what is the question? Now, the first thing I would like to say is that electrolysis is simply a chemical decomposition. And during electrolysis, there are things you should expect to happen. Things you should expect to happen. The first thing you should expect to happen is that if you have an electrolytic cell, it has an anode and a cathode. Before we come back to the question, oh my god, my anode and cathode looks very hungry. Let me try to do something about that. Okay, so I said imagine you have a particular system. You should have 2 rods. One of them has to be the anode, while the other one has to be what? Cathode. In an electrolytic cell, anode is positive, while cathode is what? Negative. But in the battery, it's the opposite. I guess what I'm saying. Good. In battery, that is electrochemical cells, anode is negative, cathode is positive. But in electrolytic cells, the anode is positive, cathode is negative. Now, what do we need to take note of in this thing? Anode is where oxidation occurs. I take it again. Anode is where oxidation occurs, while the cathode is where reduction occurs. I usually have this term in class that if you say anodic oxidation, the response should be cathodic reduction. Good. So, which means that anything that gets to the anode will eventually be oxidized. Anything that gets to the cathode will eventually be what? Reduced. The question is, what goes to the anode? Anions. It's quite simple. Anodes attract anions, which are negative ions. So if we go back to the question, let's look at the question. They said, what change will occur during the electrolysis of brine using carbon electrodes? Brine is a saturated or concentrated solution of sodium chloride. So which means that once you are considering brine, brine is simply a conc or saturated solution of sodium chloride. Now, it means that because it is a solution, an aqueous solution, it doesn't contain the metal alone. You are considering that if you look at this table now of brine, you have that you have NaCl and you have water. The cations in that mixture would be sodium, and then here is hydrogen, while the anions will now be chlorine and OH. So remember I said anode will attract the anions. So these guys would actually go to the anode, which means here you have Cl minus and OH minus. While the cations will attract, sorry, the cathode will attract cations, which is Na plus and H plus. Okay, let's look at our options to see if now if you look at option A, let's consider option A. We'll get to, we are not done with the explanation, but if you look at option A is definitely wrong. Why? Chlorine will never go to the cathode.
Yeah.
Where will chlorine definitely go to?
Anode.
The anode. B says we'll get to B. B may or may not be correct. C may or may not be correct. D, we will still discuss that. E, the volumes of hydrogen and given off during the time are equal. Okay, we'll get to discuss all these things. But just note that A is obviously wrong. Why is it wrong? Chlorine does not go to the cathode. Where does chlorine go to? The anode, because it is an anion. Okay, now let's come to the actual discharging of these ions. There is a general notion, a general principle in electrolysis, and that is weaker ions are preferentially discharged. That is the general notion. Weaker ions are preferentially discharged. Okay, if you don't mind, I would like to let's take away the question for now and just do a quick revision on some of these principles so that I will now get back to it and answer. So, where is my board? Okay, very good. It's here. Now, okay, so the principle is when you talk about discharging of ions, as I said the first principle is that weaker ions are preferentially discharged. How do we know the ones that are weaker? Very simple. I have a mnemonics. King can now marry all Zarian female slaves, provided he could mercury, silver, gold. That is for positives. The negatives are Okeke, Ivan, brought Clara, nonsense, sun, flowers. Now this is very, very simple. Okeke, Ivan brought Clara, nonsense, sunflower, basically. Then this one is king can now marry all Zarian female slaves, provided he could make rich silver gold. Now, the positives, anyone that is above is stronger. Anyone that is above is stronger, while the ones that are below are weaker. For negatives, the ones that are above are weaker, while the ones that are below are stronger. Now, the general principle in discharging ions is weaker ions are preferentially discharged. So just have that in mind. Now, but there's a problem. Okay, which means that in this case, sodium and hydrogen, between sodium and hydrogen, who should be discharged at the cathode? Hydrogen should be discharged at the cathode. Why? Because hydrogen is weaker. Now, but there's a little problem or clause to that. That particular exception is when you have concentration. If you have concentration, you don't consider ECE first. ECS, sorry. You don't consider ECS first. What you consider first when you have concentration is the concentration of the ions. Now, before you consider concentration, check if the ions are closely positioned. The number of ions apart is 3. Once they are more than 3 ions apart, they are far. But if they are within 3, they are close. Let's count to see. We have sodium and hydrogen competing. So we have 1, 2, 3. It's already more than 3. 4, 5, 6, 7, 8. Like 8 places apart is far. So because it is far, once you have that the ions are far from each other, don't consider concentration. What you should consider is weaker ions are discharged. So in this case, hydrogen will be discharged at the cathode. I hope I'm communicating. Good. Those online, I hope you're also following. So now listen. In this other case now, we are now dealing with at the anion Cl and OH. Let's see if they are close. 1, 2, 3. Yes, they are close. And because they are close, we are not going to just consider weaker ion. What are we going to consider? Concentration. Why are we considering concentration? They mentioned concentration in the question. They didn't mention it directly. They told us brine. But every chemistry student should know that brine is concentrated solution of NaCl, which means Na is concentrated, Cl is also concentrated. Now, between Cl and OH, normally we should have taken OH, right? But I told you that once concentration is involved, the more concentrated ion is preferentially discharged. But that is if the competing ions are closely positioned. So in this case, chlorine will be discharged. In this case, hydrogen will be discharged. That is the first thing. Now, having agreed on these things, I think our next line of thought should now be, what do we mean by discharge? Now, we agree that chlorine is discharged. Chlorine is a negative ion. And I would like to say this, anions, when they get to the anode, they are discharged by oxidation. Why? At the anode, what happens there is oxidation. Now, the question is, what is oxidation? To understand oxidation, I have this simple acronym, which is oile rige, oi ion radon. Now, we might not be using O ion radon basically here because in redox, in electrolysis, we are dealing with electron transfer. So what is oile rige? Oile rige is oxidation is loss of electron. Regain is reduction is gain of electron. So anytime you hear the term oxidation, it means loss of electron. Having said that, let's come back to our anion. We said that the anion will go to the anode, and amongst them, the one that is going to be discharged is chlorine. When chlorine is discharged, it is not going to be discharged by reduction, it will be discharged by oxidation. And what is oxidation? Loss of electron. So chlorine will lose electrons and have Cl2 gas produced. Now, we are not done with this. Let's balance up. We have 2. Balance the electron. Let's do 2 times 1 in this case. How many electrons? 2. Okay. Now, hydrogen was discharged at the cathode. These are the anode. These are the anode. The cathode, who is discharged? We have the hydrogen is discharged. If hydrogen is discharged, you are going to have H plus. At the cathode is reduction, and reduction is gain, right? So what do we have? Plus E minus, reacting to give hydrogen gas. And when that happens, balancing, you have 2, which means how many electrons? 2 times 1, 2. Automatically, we have this. Now, let's bring up the question and now check what should be the answer. Let's look at the options and see what the answer should be. Okay, where is what? Oh, very good. Okay, so looking at the question, they said what changes will occur during the electrolysis of brine using carbon electrodes? Option A says chlorine will be given off as the cathode. That is categorically wrong, because where chlorine gas was given off is where? At the anode. Very good. Option B says oxygen gas will be given off at the anode. No. Based on what we just did, what was given off at the anode is not sorry, Flora, Nena, I'll get back to you on what I just said. And it's not oil ion. Okay, let's continue. I'll get back to O ion radon. So hold on. Now, back to what I was saying. Option B says oxygen gas will be given up at the anode. But based on what we just did, what was given up at the anode is not oxygen. As we can see, it is chlorine. You get? And we remember the reason. Normally, it would have been OH2, but because we consider concentration for close ions, the concentrated ion is chlorine, so it's discharged. Now, so that is why chlorine was given off at the anode. Option C, sodium will be deposited at the cathode. As we can see on my screen, at the cathode, what was given off was not sodium. What was given off was what? Hydrogen. Simply because I told you guys that the weak ions are preferentially discharged. And even though sodium is more common, because it's not close, we're not going to consider concentration. Okay, then we go to the next option. Option D, the resulting solution after electrolysis will be acidic. Okay, let's see that. Let me explain what that statement means. I think I have to go to my board. Okay, now look. Okay, where's my pen? Good. So if you look at this now, and we have a setup. Given that this is the anode, we said that chlorine will come and OH will come here. Here, hydrogen will come and Na will come. Now, please, who was removed from our reaction? Chlorine was removed, right? Yeah. Who was removed in this side? Hydrogen. Now, did you notice that what is remaining is sodium hydroxide? Yeah. Is it acidic or alkaline? It's alkaline. Are you getting what I'm saying? Yeah. Now, anytime you are removing hydrogen ion, you are actually reducing the acidity, because hydrogen is what makes it acidic. So when you're removing hydrogen, the acidity is reducing. But if I was removing OH, what am I reducing? The alkalinity. If I remove the both of them equally, it means that the solution will remain neutral because both of them left. But here, you left OH and removed hydrogen, which makes this solution alkaline. So, but the option we can see on the board is that the resulting solution is acidic. It's not acidic, it's alkaline. Please, do we need to even go further to explain the last one? No, our answer is E. Now, to explain is E. Eh? What is E? E is the volume of hydrogen and chlorine given off during the same, the volume of hydrogen and chlorine given off during the same time intervals are equal. That is correct. Why? Now let's go back to the board. Let me try removing this thing. If you look at the screen, thank you. How many moles of chlorine was produced? How many moles of chlorine? 1. How many moles of hydrogen? 1. Are they not equal moles? Yes. Now, you might not understand this directly, but just have this in mind that equal volume of gases contain the same number of moles, and that is Avogadro's law. So once they have equal number of moles, they have equal volume. You guys get what I just said?
Yeah.
Now, why the answer is this is simply because their number of moles are the same, and once their number of moles are the same, their volumes are the same. And if we look at it, the option to number E says the volume of hydrogen and chlorine given off during the same time are equal. Questions? Okay, so someone is asking why is it that sodium is not deposited at the cathode, right?
Not why. I mean, what is the answer?
Okay, why isn't it the answer? Because according to what we just did, the experiment we did you notice that at the cathode, what is actually giving off is hydrogen and not sodium?
Okay, deposited and giving off.
Yes, deposited and giving off is like practically the same thing. Okay, I think I now understand what you mean. Now, the fact that it is attracted to that particular, the fact that it's attracted to the cathode doesn't mean that it's discharged. You get? So if you are asked discharged, let me also say this. When you are asked discharged, your answer is an ion. When you are asked deposited, you are looking at a neutral substance. If I say discharge and I say Na, Na is wrong. But if I say Na plus, there's a chance. Am I communicating with you? So, however, the fact that it is attracted to the cathode doesn't mean that it's going to be discharged. The one that is discharged has to follow the principle. And based on all we did, we thought that the principle here, the anode will be discharged and the cathode will be discharged. Sorry, chlorine will be discharged at the anode and hydrogen will be discharged at the cathode. Basically, that is that. Okay. Let me reiterate what I said about O-ion radon for Flora. Now, O-ion, I said oile rigate is oile rigate. So you can go about greeting people like this. Yes, somebody is going to beat you. You tell the person oile rigate, the person should respond what? O-ion radon. So oile rigate is oxidation is loss of electrons. I think you can guess that reduction is gain of electron. Now, what's O-ion radon? O-ion is actually oi-ion. This is like II. So what does that mean? Oxidation is increase in oxidation number, while radon, reduction is decrease in oxidation number. My handwriting is terrible. You guys should manage. Okay, so that's that basically. Okay, so an inventor is asking, is deposited and discharged the same thing? Deposited and discharged are not the same thing. Let me explain. If we look at this particular, when you say discharge, discharge means removing a charge, which means for you to say discharged, that thing has to have a charge. I take it again. Discharged simply means removing a charge. So when we are considering the cathode, we are considering the cathode. It's hydrogen that was discharged, right? Yeah. Good. Now look at it. Hydrogen has a charge. This hydrogen ion, has a charge. That is the only reason it can be discharged. Which means any neutral substance cannot be discharged. The only substances that can be discharged are substances that have charges. So the charge means remove this charge. How are we going to remove this charge? At the cathode, reduction, right? and reduction is gain, so plus electron reacting to give hydrogen gas. Now hydrogen, this one now, this hydrogen gas was deposited. After it was discharged, hydrogen gas was deposited. Hydrogen ion was discharged, as you can see on the screen, to give hydrogen gas. So the product of a discharge is the deposited substance, or the one given up, or the one produced. They can use different terms. But when you say discharge, you are considering the ions. I hope I'm made myself clear. That's to that should be an immense sum. I hope you understood this. Okay. And if they are going to achieve the neutral state. No, no, pure Autumn. I hope Autumn has taken this correction. Autumn and Animesoma, they are not the same thing. When you are discharging, you are looking at an ion. When you are depositing, it is the product of the discharge. Okay, let's go to the next question quickly and step it up a notch. Okay, next question. Okay, so they said equal moles of ethyne and hydrogen iodide reacts to give dash. Equal moles of ethyne and hydrogen iodide reacts to give dash. Okay, let's give me your thoughts first. Your thought is D. Where is D?
CH2.
CH2 CHI. Ah, okay, okay, okay. Let's solve this question. Now, how are we going to solve this question? Very important to note that it says equal volumes of ethyne. Now, what is ethyne? You know that when you are considering this reaction now, you are considering an addition reaction. I presume everybody knows that.
Yeah.
You get. So you are considering an addition reaction, which means you only have one product. Now, I prefer to write a structural diagram when I'm reacting these things. It makes it easier to understand. You are saying B. Let's prove it. The answer should be D. So let's see. C, ethyne is C triple bond to C, and which means the only remaining thing is hydrogen here and hydrogen here. How did I even get CH2? Ethyne's general molecular formula is CnH2n minus 2, which means if the carbon is 2, it will be 2 times 2 minus 2, which means C2H4 minus 2, which is 2. So that's why ethyne is C2H2. But besides that, everybody in this class or that is preparing for this JAMB should know that yne, YNE indicates triple bond, and earth is 2 carbons. So 2 carbons that have triple bond will be represented like this. Now, they said it is going to, this is 1 mole, oh. So it is going to be reacting with an equal volume of hydrogen iodide. The basic principle in this reaction is this: one of the elements attacks one of the carbon, while the other element attacks the other carbon. Now, why they are attacking it is just to cut a bond. If they cut it, this particular element will collect that bond. This other element will collect the other one. So with that said, what you have is this. If you say, hey, point to note is in the question they said equal number of moles, right? Equal moles of ethyne. Thank you. So because it is equal moles of ethyne, you must take note that if this is 1 mole, here should also be 1 mole. That's why we are not even balancing it completely. If they are said a complete reaction, that is a complete saturation reaction, that means we'll have 2 moles here. You get, but because they said equal, if here is 1, here is 1. So let's see what happens. H will be attached here, and you're going to have CHH. Now remember that whenever an addition reaction occurs, you break a bond, which means that the remaining bond that will be here is double bond instead of triple. See, then we come here, I will attack. Originally H was here before, and if I attacks is I. Now if we write it as it is in our option, what we have is CH2 double bond CHI. That is option B. Have that in mind. So please take note of that. Those of you that answered B, Chikamso Favor, Izine Maduagu, I hope this is understood. Okay, now let's move ahead. Next question. Next question. Okay, next question. Oh, okay. I presume we can see this question. Yes. What do we think is the answer? In an electrochemical cell, polarization is caused by dash. Oh, those of you in this class, you are not seeing it, but let me rearrange it. Polarization is caused by dash. Can you guys see it?
Yes.
So what do you think is the answer? Hydrogen, I think A. Oh, wow, come to D. Blessing. Okay, okay, okay. Let me explain. I'll do that quickly. Now, there are two battery defects. I think we should write if we need to. There are two major types of battery defects. Number one is polarization. Now, what is polarization? You can write. Polarization is a battery defect. Polarization is a battery defect in which polarization is a battery defect in which the interaction between the electrode and electrolyte in which the interaction between the electrode and the electrolyte is prevented by a substance. So anytime the interaction between the electrode and the electrolyte is prevented or stopped by a substance, what you refer to that thing as is polarization. So imagine for instance you have particular battery. Let's say for instance here the anode chlorine and maybe something else, let's say OH minus. Normally the anode should be interacting with it, you get. But when you have things blocking this particular anode from interacting, automatically the type of battery defect is called polarization. Now the major gas that causes polarization is hydrogen. So you can put that down. That the major gas that causes polarization in battery is hydrogen. Now, extending this particular statement, once you notice that hydrogen is what is causing the polarization, if you are going to resolve or bring about a remedy, the remedy to polarization is simply removing hydrogen. And what do you think is the best way to remove hydrogen? Does anybody know? Huh? Okay, those online, what do we think? How do we remove hydrogen? I'm waiting for answers. What do we think is the way to remove hydrogen? Because I said polarization is caused by hydrogen. If you are going to bring about a remedy, you simply remove that hydrogen. How are we going to remove hydrogen? Is there any idea online? Okay, if none, I'll have to continue. So the basic thing is this. How do you remove hydrogen? By oxidation. Once you oxidize hydrogen, you have removed it. Is it not? Not be so.
That's like a normal
H2 plus oxygen. What do you have? H2O. If water is there, it's no problem, provided hydrogen is not there. I get what I'm saying. Now, however, you won't just say oxidation. Usually, what is referred to it as depolarization. You get, so which means you won't put direct oxygen to hydrogen and it just goes out. You know, there's a different condition. You need better catalyst. But if you want to oxidize hydrogen and without oxygen directly, you use oxidizing agents. So once you introduce oxidizing agents into the battery, and it removes hydrogen, automatically you have resolved the problem. Those oxidizing agents are referred to as depolarizers. What did I call them? Depolarizers. So remedy. Let me confirm if we still have connection. Okay, yes. Just give me a little time. I want to go and confirm. My connection is wavering a little bit. If you know say you dey use my hotspot, oya off your Wi-Fi.
Praise God. Praise
Check
God.
your hotspot. Praise God, off your hotspot. Oya be fast, go and off it.
Wait, am I joining?
No, not you, because you are my monitor. Give me. Okay, sorry guys, I had to take Jesus. Why is it no longer live? Okay, I hope you are still live. Yeah, I think it should be live. Okay, let's continue. Now, let's continue. As I was saying, so I said the remedy is introducing depolarizers. And when you see MnO2 in a battery, the function of MnO2 in that battery is that it's serving as a depolarizer. Okay, so have that in mind that MnO2 is a depolarizer. Okay, let's move on to the next question. That's that basically. Okay, I think you can also use other oxidizing agents. It's just that this one is most preferred when you are dealing with a battery. Okay, next question. Okay, let's remove our, what is this here? How canals distinguish? Okay, okay. So the next question. Rose and Ozike. Praise God. They say you should fear God. Okay, so let's look up. Alkanals can be distinguished from alkanones by the reaction with dash. What do we think? Let's look at this question properly and answer. Alkanals can be distinguished from alkanones. Those online, give me your answer. Alkanals can be distinguished from alkanones by reaction with what? Okay, D from Anime Soma Ono Zoom. Okay, sorry. Zimozo. Sorry, don't mind me. Munachi Dimma. Okay. See Onya. Okay, yeah, I'll stop. The answer is D. The answer is what? D. I will tell you, let's start with what A is used for. A is Sudan 3 stain and it is used to test for fat and oil. So you can be jotting these things down. Sudan 3 solution is used to test for fat and oil. B is starch iodide paper. You can see starch there. So what does it mean? It's used to test for starch. C is a reducing agent. Lithium tetrahydroaluminate 3 is a reducing agent for most organic compounds. And finally, D, which is Fehling solution, is both used to test for carbohydrates and distinguish between alkanals and alkanones. Let me explain what I mean. I'm taking this out so that we can have space to write on the board. Can you see this thing? You want to write it? I'll put it down again. I'll bring it up. The third one is a reducing agent. Yeah, that backward guy. Okay, so listen. So what do we mean by that? First of all is that for those of us that already know this is one of the reactions of alkanals. Listen, when you have a primary alkanol, first of all, it is first oxidized. I think I should write this in details. Let me write this in full. Okay, let's say we have primary alkanols. Primary alkanols. When you oxidize a primary alkanol, that is oxygen, what you are going to get is alkanal. And then it can be further oxidized to what? Alkanoic acid. So for some of you that have never come across this, please put this down. Secondary alkanol, on the other hand, can only be oxidized once to give alkanone. Alkanone, no reaction. On further oxidation, there will be no reaction. So what is this trying to say, or what am I trying to say? Now, anytime you react any oxidizing agents with alkanal, to react. But with alkanone, it will not react. Why? Alkanals can be further oxidized, but alkanone, this is where they stop. Am I communicating? Now, the other thing you need to take note of is there are three major reagents that can serve as oxidizing agents. Number one is Fehling's. Number one is Fehling's reagent or Fehling's solution. This one turns brick red. When it enters alkanals, it will oxidize alkanal and the color will change to brick red. But if you put it in alkanone, there will be no reaction. Why? Alkanones cannot be oxidized. The second important reagent is Tollens reagent. Tollens reagent will cause a silver coating. Tollens reagent will bring about a silver coating. Number three is acidified AMNO4. This one will turn from purple to colorless. Remember, these color changes will occur only in alkanal, but when it goes to alkanone, your answer will be no reaction. Okay, so I guess I have done justice to that. Acidified KMNO4. Acidified KMNO4. Okay, ma? It's K2CR2. Alkaline. Okay. It's to colorless, but alkaline. If it is alkaline, it will turn to brown. Okay, let's see this. Oh, wow. Okay. Which of the following? Okay, so let's try this question on the screen. I think this is an electrolysis question, so you all try it. What do we think? Those of you online. So yes, what do we think? Has anybody gotten an answer? Someone says the answer is B. Praise God. Praise God says the answer is B. Oh, sorry guys.
Wow, there are a lot of answers.
Sure. Sorry, I'm trying to set up one more slide. Okay. So yes, what do we think is the answer? A lot of answers online already. B, C, D. What? Okay, I think we'll have to solve it. Sorry, I'm trying to. Okay, let's solve this question. Let's solve this question. What does C for? Okay, I'll do that. I'll recap. That's what's his name? What's her name? Metformin. Now, everybody listen. When you have this kind of scenarios, when you have this kind of scenario, it's quite easy to handle. First of all, is which of the following ions require the largest quantity of electricity for the charge of an electrode? I would like to say that number of moles, quantity of electricity is equals number of moles of electrons times Faraday's constant. If you don't have this formula, you can put it down. Quantity of electricity is equals number of moles of electrons, N of electrons times Faraday's constant. Number of moles of electrons times Faraday's constant. Now I will show you the official way to find it and show you the unofficial way to find it. Now, which one should I even start with? Official or unofficial? Official. Now see the official way to solve it. The official way to solve it is this. Simple. As I said, Q is the number of moles of electrons times Faraday's constant. So let's look up. In the first option, we have 4 moles of chlorine. 4 moles of chlorine implies that Cl minus plus E minus, sorry. Okay, so let's take this again. So when you are discharging 4 moles of chlorine ion, it's quite simple. The first thing you need to know is that chlorine is an anion, right? It will be discharged by lots of electrons. So minus E reacting to give Cl2 gas, balancing 2 here, right? The number of electrons here is how many? 4. Which means the quantity of electricity will be 4 times F. Understood? Good. We go for the next one. Option B is 3 moles of sodium ion. Na plus is going to be discharged by reduction, which means we are going to have Na. How many will be here? 3. Remember how I got it? This number times this number. Then you go to the next one. So which means Q is going to be 3F, right? Then for the next one, it is 2.5 moles of Cu. Abi? Cu2 plus cation. So it's going to be 2.5 times 2 is 5, right? So here will be 5F. Abi? Right? And then the last one will be 2 times 3, which is how many? 6F. So which one? What's the answer? D. Because that's the one that has the highest quantity of electricity. So you didn't get this.
So I think like I don't get why.
Why I need to times those
No,
things?
not it. Like I thought the reaction is supposed to be like this. I think it's supposed to be like this.
Okay, so let me explain again. Now listen. If you have an anion is discharged at the anode. An anode, what occurs at the anode is oxidation. And as we know, oxidation is loss of electrons. So the emphasis is this. Once it is an anion will not undergo reduction, it will undergo oxidation. Oxidation means loss of electron. So that's why for the first one, which is 4Cl minus, we minus electrons. Did you get what I just said? So if you minus, you're going to get chlorine gas balancing 2. But here now, I told you how to get this number of electrons. This times this, you get 4. So for here is 4, which means 4F, because Q is equals number of moles of electron is 4 times F, right? Good. For the second one is Na plus. But how many? 3 moles. Please, once it's a cation, you add electrons to discharge it, reduction. So you have Na. How many electrons is going to be involved here? 3. So here is 3F, right? Then for the next guy is 2.5 moles of Cu2 plus. This is 2.5 times this, which is 5 electrons, right? What do we have? 5F. What we have there is 5F. And then finally, we have 2 aluminium, 3 plus. So what do we have here? 2 times 3, 6F. Once you do this, the one with the highest quantity of electricity is aluminium, and that is your answer. I hope this is clear. Good. Those online. What did they say? Which of the following ions require the largest quantity of electricity? Yes, now aluminium is the answer. Aluminium is 6F, C is 5F, 3F, 4F. Okay, what if I had asked the lowest? The lowest will now be sodium, right?
Yeah.
Good. The lowest will now be 3 moles of sodium, but the highest here is 6 moles of aluminium, basically. Okay, I should reiterate. This is the 3rd time. Okay. Now let me just explain this finally. This is the last time I'm going to explain it. If you don't understand, this is a video, which means you can review it. That's why it is a video. You can go back and rewatch. I'm explaining for the last time. Listen. Option A, I've given you a general formula to find quantity of electricity using number of electrons, and it is Q equals number of moles of electrons times F. I don't want to put the value of F, it's not necessary. F is 96500, but you can solve without that in this case. Now, the first question says 4 Cl minus. That's 4 moles of Cl minus. If you are discharging Cl minus, you have to lose electrons. It's a constant thing, and you get chlorine gas. Now, but how do you find this thing here? It's very simple. This number times the charge, 4 times 1. Forget the minus. 4 times 1 is 4. So here is 4 electrons. Now, which means quantity will now be how many electrons? 4 times F. Simple. Do this for the second one. The second one, Dimuzo, we'll get to your question. Please, can we take this thing accordingly? For those of you that are talking about different things from what we're discussing, just chill it out, okay? Okay. Is there a short way to solve it? I'm getting to that. Now, next one is 3. Abi? So you have 3 moles of Na plus, and you have plus electrons reacting to give Na. The number of electrons here is 3. So how many F? 3F. Do the same thing for the others. For this second one will be 2.5 times 2, 5F. The last one will be 2 times 3, which is what? 6F. Now the shortcut is this. Look at this thing. Now times this by the charge. 4 times 1, 4. You write 4. 3 times 1, 3. Write 3. 2.5 times 2, 5. You write 5. 2 times 3, 6. Which one of them is the highest number here? D, and that's the answer. So once you look at the one that is the highest number there, that is the answer. So JJ, I presume you got what I just said. Now, moving ahead to the next question. The next question, where's my mouse? Okay, yes, very good. Okay, so back to the next question. The next question has to do with empirical formula. So let's try. Everybody try out this question.
This one.
And you are not supposed to hear something now. I'm giving you time. Somebody is giving me answer online. Give me the answer now. Those of you that cannot hear, I intentionally put up the mic so that you know. Yes, is there no answer online? Abi make we solve? Okay. Should I? Mesoma joy. You are not. Whenever I tell you to solve question, it means that you are not going to be hearing anything. That's the implication of solve question. I want to give people quietness so that you will solve. Do I have an answer yet? Should I? Where's my joy? Ugoke Stephen, I want to join the audio. I don't understand what you mean. I don't understand what you mean by incoming. Sorry, by you want to join the audio. Can't you hear what's going on? Okay, Anosike has given me an answer and I'm going to solve. Anosike says, Rose says it's A. Let's solve. Let's solve. Those of you that are here, more you are talking, you're distracting me. So you know. Okay, so look up everybody. This is quite simple to understand. Let us look at the question. It says a sample of a substance containing only C and H. Okay, so solving the question, quite simple. The very first thing I think we need to take note of is they said a sample of a substance containing only C and H, which means it's a hydrocarbon, CXHY. Let's take that. Burns in excess oxygen. Oh yeah, whenever a hydrocarbon is burning in oxygen, we all should have known by now that anytime any hydrocarbon is burning in oxygen, the only product it's going to give is CO2 and water. So have that in mind. Anytime a hydrocarbon is burning in oxygen, the only product it's going to give is CO2 and water. Now they now said to yield 4.4 grams of CO2 and 2.7 grams of H2O. The empirical formula of the substance is dash. Now, anytime you are asked to solve empirical formula, what you need, there are two things you need. The very first thing you need is the mass composition of the carbon, that is in this case, and the mass composition of hydrogen. Now, how do we get those things? Because they were not given directly. What they gave you was the mass of CO2 and the mass of water, not carbon and hydrogen. So how do we mass of carbon from CO2 and mass of hydrogen for water? Now, it's common sense to notice that all the carbon in this hydrocarbon, see where it is inside CO2, and all the hydrogen is inside water. Which means if we do mass composition, that is a kind of percentage, to find the amount of carbon inside that CO2, what do? We do C out of CO2 times the total mass, which is 4.4. And to find water, we are going to do H2 out of H2O times 2.7. Why are we doing this? Inside 4.4 of CO2, what is the amount of C? Another way to illustrate this thing or to help you easily understand it is this. If CO2 is equals 4.4, the carbon inside will be equals X. I hope this is understood. Those online, are you following? I take it again. If CO2 is equals 4.4, the carbon inside that CO2 is equals what? X. So let's find it. What is the molecular formula of CO2? You need to understand that. What's the molecular formula of CO2? It's 12 plus 32, right? We all know it, everybody here should know it's 44 now. So 44 is equals 4.4, Abi. So carbon, which is 12, will now be equals what? X, right? Cross multiplying, you find out that X is equals 12 times 4 point all over 44. I think that should be 1.2, right? So which means the mass of carbon, which is X, or the mass composition of carbon, mass of carbon is equals 1.2 gram. That is the first thing. So if you are going to put this down, please do this now. Those of you that want to put this down, please put this part down now so that we can move ahead. And if you finish writing that, find that of water, find that of hydrogen, sorry. Find the mass composition of hydrogen inside H2O. So in that case, it will be H2O equals 2.7. Therefore, hydrogen alone will now be equals Y. So let's do that quickly. This is not a direct stoichiometric question, but you know, it applies. Okay, what did we get for hydrogen? 0 point. And let me just remove this. You got 0.3. Let me just remove this thing first. 0.3. Okay, let's solve for hydrogen. Let's solve for hydrogen. Now, hydrogen zone is water is equals 2.7, right? Then hydrogen, there are two hydrogens, so H times 2, right? Will be equals Y. Water is 18, equals 2.7. H times 2 is 1 times 2, which is 2, will now be equals Y. So what do? We cross multiply. So we have 18Y is equals 2 times 2.7. Dividing by 18. Dividing by 18. Cancel out, cancel out. 3 here is 6. 3 here is, yes? 3 into 27 is supposed to be 9, right? 0.9 abi 2 1 2 here 3 3 here 1 0.3. I presume, so please, I think you should resolve. If you resolve, you get 0.3, or you look at what I'm doing now. When you do this, come to why you got 0.1 is probably because you did not use H times 2, or maybe one of the errors. However, what we have now is 0.3. So we have that the mass of hydrogen is equals 0.3. Now, we've not gotten our answer. This is now the point where we are now going to solve empirical formula. Now, let's apply the principles of empirical formula. First rule, identify the constituent elements. That's the first rule. So if you want to now solve empirical formula, identify the constituent element. They said it contains only carbon and hydrogen. Second rule, identify the mass composition. What did we get as the mass composition of carbon in this compound? What do we get? 1.2, right? Then of hydrogen, what do we get? 0.3. Now, after you've gotten this, the next thing is divide both sides by the atomic masses. Divide here by 12, which is the atomic mass of carbon, and divide here by 1. If you divide, I think we have 0.1 here, right?
Yeah.
And here we have 0.3. Now, once you do this, the next thing you do is divide both sides by the smallest number. Between 0.1 and 0.3, which one is smaller? 0.1. So divide by 0.1, 0.1, and you have 1, 3. And that's that. So which means your empirical formula is CH3. Easy, right? Okay, so I presume this is understood. Those that are following us online, hope you are still following. Okay, Mba Ndubisi, can you please increase your video quality? If you tap your screen, you will see something that looks like a setting symbol. That's like a gear. Click on that gear and then you will see resolution change. You can increase it. Probably your phone is set at 144. Change it to at least 360 and then it will be clear. Okay, let's continue for want of time. Okay, the next question we are going to be looking at, is okay, so what do we have? Let's attempt this question. See, those online, we are still waiting for your answers. Uncle, please, is there a shorter way? Okay. Is there a shorter way? I would have loved to say yes, there is a shorter way, but listen, I think what basically applies to this question is if you have come across it multiple times, you just know what exactly to do. So there's no like direct shorter way. If I wasn't teaching this question, I think it would have happened faster. It's just that I was explaining and writing. You get? It's still possible. Just look through the method, know what to do, know exactly what to do. It then saves your time basically. But I don't think there's like a short way to get this thing. Not that I know of. This is basically, and this is actually quite simple to do. If you do it yourself and you understand it, you can actually do it faster. Okay, I think answers are coming in, and some of you said C. Urgent said A, and Emesoma said C. Okay, let's consider the question. The temperature of a body decreases when drops of liquids placed on it evaporate because how? The temperature of a body decreases when drops of liquid placed on it evaporates because okay. So this is quite simple. First of all is this. If, for instance, a body vaporizes or a particular liquid evaporates, it evaporates by absorbing heat from any body it is found on. The implication is that once it absorbs heat from that body, the temperature of that body will decrease. Now, the heat that it absorbs for it to be vaporized is called the heat of vaporization. So if you look at option A, it says the atmospheric vapor pressure has cooling. No, that's not the reason. That's not the reason. Option B, a temperature gradient is nah, that's not the reason. Option C, the heat of vaporization is drawn from the body, causing it to cool. Yes. So as I said, anytime a body wants to vaporize, it actually takes heat from another body, and as it takes that heat from another body, it now vaporizes. The heat it takes from another body to vaporize is what we refer to as the heat of vaporization. So just have that in mind. The answer is C. Why is it C? Anytime a body is evaporating, it collects heat from another body. Okay, and that heat that it collects is called heat of what? Vaporization. Okay, next question. Which of the following are structural isomers? I have discussed isomerism in some of the videos online. Those of you that have not subscribed, please go and subscribe. It's important you do so. Subscribe, like the video. I'm not seeing likes yet o. Una dey learn something shey? If you dey learn, just click like button and then subscribe if you haven't. Okay, so they said which of the following are structural isomers? What do we think? Oh, sorry. Are we answering this question or propanoic acid and propan 1,2-diol? Kamso, are you responding to the question we have like right now? Yes, yes, yes. If you're responding to this, please indicate. And Imesoma says she thinks B. Okay. Now let's answer this question. Under structural isomerism, we have chain isomerism, we have functional isomerism, we have positional isomerism, we have metamerism, tautomerism, and ring chain isomerism. These are all the forms of isomerism under structural isomerism. However, the one I want to emphasize here is functional isomerism. So please listen. There are three groups of elements or compounds that you should take note of in functional isomerism. The three groups of compounds are number one, alkanals and alkanodes. Alkanals and alkanodes. Once they have the same number of, okay, let me use the term corresponding alkanals and alkanodes. Corresponding alkanals and alkanodes. So what do I mean by that? What I'm simply trying to say is that once an alkanal and an alkanode have the same number of carbon atoms, they are isomers. Have that in mind. Corresponding alkanals and alkanodes are isomers. Take for instance, I say propanal. Propanal is C, 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 double bond O, H. Here is H2, here is H3. This is propanal. If I say propanone Propanone is C1O. Prop means 3 now. H3, H3. Now, what is the number of carbon atoms? C3. Number of hydrogen is 3 plus 2 plus 1, H6. Number of oxygen 1. In this case, same thing.